Great. Okay, so I'm going to talk about high tunnel strawberries, but to start with, I want to talk a little bit just about general strawberry management. And this is a little bit of a review from what I presented last year, but I want to go into kind of the general biology of strawberries first, and then focus on high tunnels, which is the one area of cold protection that Sheridan didn't touch on, but is an important one when it comes to strawberries. So just a little bit of an overview here of the kind of the annual life cycle of strawberries. So what we have is we have this period of dormancy that she talked about, going through the fall, and this is labeled by month. And then as we come into warmer conditions, depending on where we are, the temperature starts to warm up. We shift from this from endodormancy here to ecodormancy, and then as we shift out of, as we get warm enough weathers, then things start to emerge from dormancy. And in as typical in a lot of areas in the northern hemisphere, we get flowering in late April into May, and then the fruit ripens in June. And so most of the varieties that have been around for a long time are referred to as June bearing types. And then, so what happens with the June bearing type is it fruits in June, and then you get stolons or runners forming. And then as the days get short, the temperatures get cool, they make flower buds for next year. So they start to initiate the flower buds in the fall, but the flowers stay down in the crowns and then emerge again in the spring. So that's the June bearing type. There's also one that's called ever bearing. There's also day neutrals, and they're a little bit different in terms of how they behave or how they react to environmental conditions. But in your field or in gardens, they typically are very similar in that they can produce fruit through the summer as long as the temperatures are favorable. And typically what that is when the temperatures are below about 85 degrees. Once we get above 85 degrees, they tend to not want to flower and fruit, and they kind of go a little bit dormant in terms of not producing more fruit until into the fall. So in a field situation, in a garden that's not protected, they'll flower and fruit some in the spring, maybe beyond a little bit what the June bearer does, and then they kind of slow down, and then in the fall they'll start to flower and fruit again. Historically, with the way strawberries were grown, was this matted row approach where they're spring planted with cold stored dormant plants, usually larger spacing, a couple of feet between plants. In that first year, they're just allowed to runner, and they fill in these beds, and you get this appearance. So you got these solid mats of strawberry beds, and then here they've got straw in between the rows. But that whole idea is that you get a bunch of daughter plants forming that first year, and then those daughter plants produce the fruit that you're interested in. One of the challenges with matted row or with any type of strawberry production is cold, and Sheridan's gone into a lot of detail about that, and I'll just touch on a few things here. So one of the approaches, if you're in a very cold climate, is straw mulch. So putting straw over the beds in the winters, particularly for the coldest periods of the winter, so that we don't get, it doesn't get, sub-zero temperatures down into the soil. The soil does act some to insulate, but having some type of mulch, this year in the north, we're fortunate because we got snow on the ground, which serves as a mulch, but we can use straw. The other issue, and Sheridan talked about this, is spring frost protection. So once those buds start to move, once it's warm, flowers start to swell and emerge from the crowns. They're very sensitive to cold temperatures, and we get these, what they call black eyes, where this is the receptacle tissue and the pistils, and they're basically dead. So that should be yellow or green, and it's dead. So that flower is not going to produce a fruit. One of the ways that we can manage for frost protection of the flowers is actually this winter mulching. So the way this is practiced in really cold climates, this picture was taken in Minnesota, and what they do there is they wait till the ground is cold, and then they put the mulch on, say early to mid-December. So the ground is frozen, but it hasn't gotten really, really cold. And then they put the mulch on, and that actually keeps the ground cold so that the flowers emerge later. And then they pull the straw back once they start to move. As Sheridan mentioned, that they use sprinklers in other areas. We don't use them here for a couple of reasons. One, we don't have the water. The other is that in our dry environment, if we turn sprinklers on a cold, dry day, it actually cools the plants off because the water evaporates faster than it's freezing. It doesn't really work. But another approach that can be used is tunnels. And here I've got in the background a high tunnel, which is like a greenhouse type structure, and I have low tunnels. These are strawberry beds, and I'll talk more about this experiment in a minute. We don't use matted row in that system. We use what's called a hill system, which means that the plants form individual hills, like is shown here, instead of this solid mat of runners. They're fall planted at close spacing. We use fresh dug nursery plant. Well, the way that it's done in California is fresh dug nursery plants and plastic mulch. And then the runners are removed. If any of them form, you actually pull the runners off and just let that mother plant fruit. And the yield depends on how well established that mother plant is. We want it to grow and develop so that it has multiple crowns in that plant. So if you go down and look, there's growing points or crowns, and we want about 5 crowns per plant. And then they're usually kept 1 year and removed. So this is what it kind of looks like. There's raised beds, plastic mulch, and then individual plants that were planted there, but no runnering. In order to make this work in a cold climate, we need to get them planted at the right time. As I mentioned before, we want 4 to 6 crowns per plant, and we don't want any runners. And so what we're trying to do is we're trying to plant, here's this annual cycle again. I'm trying to plant late enough that I don't get runner production, but I get good, strong plant development and flower bud initiation. And the optimum timing for that is going to depend a little bit on your environmental conditions, on your local climate. What we found with our system, with growing them in tunnels, and I'll talk more about this, is our optimum timing for Cache Valley was about September 1st with a plug plant, and I'll talk more about that. So what is a high tunnel? This is really where I wanted to talk about. Tunnels are like basically a passively heated, passively cooled greenhouse, or some people refer to them as walk-in cold frames. But they're basically, a high tunnel is something that you can walk in and work within. And these are the ones that we use. There's information on our website. I'll talk about more. This is one we use for strawberries. This is 14 feet wide and about 7 feet tall at the peak, just to give you kind of an idea of scale. And we can fit three beds of strawberries in there. So tunnels, high tunnels, low tunnels, are all about managing temperature. And so basically what we're doing is we're trying to trap heat. We're trying to trap the heat that's being absorbed into the soil, as well as the temperature of the air. We can use high tunnels, we can use low tunnels. In this particular picture, we have low tunnels inside of our high tunnels, which gives us 2 layers of protection. We can use them in the field without high tunnels as well. There's also floating row covers that are used, and those just lay on the crop, and that can give us an additional layer of protection. And we've used all of these in combination, where we've covered up the row with floating row covers, put a low tunnel over the top of that, and a high tunnel over 3 rows or 4 or 5 rows at a time, depending on the size of the tunnel. So all of those are designed to raise the temperature, particularly at night. We also need to think about higher than optimum temperatures and how we're going to deal with those. We can use ventilation by opening up the tunnels, in this case, pulling off the row covers on the low tunnels and then opening the sides and the ends of the high tunnel to get good ventilation. We've also used shade, and in this case, we have a tunnel where we've pulled the plastic off from it and put shade cloth on it to try and extend the optimum conditions farther into the summer. So it's all about temperature management. This is kind of an example of what this might look like. This was measured here in Cache Valley just about this time of year, a little bit earlier. And you can see the black line there is the outside temperatures. So it was dropping down in the mid to high 20s at night. And then during the day, it was getting up to about 40 degrees outside, pretty typical. So freezing every night, but getting in the 40s. And inside just the high tunnel alone, we were getting down, it was, if you look here, it was just as cold at night in that high tunnel as it was outside. But it was jumping up to 60 to 70 degrees in the tunnel during the daytime. That's just with the high tunnel alone. So we get a little bit of night protection, not a lot. And this is kind of an anomaly. Sometimes it's getting as cold. Sometimes we're a few degrees warmer. On average, we typically are maybe a couple of degrees warmer than outside. But if we add a low tunnel inside of that, okay, now we've kept the temperatures significantly warmer at night. We're pulling the low tunnel back during the day and ventilating. Otherwise, it could get even hotter than this. But so we're getting that temperature lift by having two layers, we're getting a little bit more protection at night. So the purpose of a high tunnel, there's multiple purposes. My primary objective, the first thing I want to do, if that strawberry plant is getting to the point where it might be damaged by cold injury, if those flower buds are starting to push and I don't want them to freeze, my first objective is to keep them from freezing. Okay, so this line shows me basically the response in terms of growth to temperature from really cold temperatures to really hot temperatures. So down here, I might get cold injury. So my first objective is to keep the temperature above that point where I'm going to get cold injury. Okay, my second, let's see if I can. Okay, and that's the kind of cold injury I'm trying to avoid, particularly in the spring. My second objective is to keep the temperature above the base temperature for growth. So although if it's in the 30s, even high 30s, it's cold, it's warm enough that those blossoms aren't going to get frozen, but the plant's really not growing until I get above some critical level. And so once I get above that critical level, the warmer it is, the faster the plant wants to grow until it gets to some optimum. So my second objective is to keep it above the baseline so that it continues to grow. And then my third objective is to keep it in that as close to that optimum temperature as possible for as much of the day as possible. So here's an example from a strawberry tunnel that was here in Cache Valley. The green is the temperature in the tunnel, outside during this particular week, and the magenta color there is the temperature in the tunnel. So my first objective is keep the blossoms from getting injury, and that depends on the stage of development. Sheridan showed those stages of development for different fruit trees. When the bud is tight, it can tolerate 24 degrees. When we get to petal fall, it's about 27. And there's periods in there where it's 27, 28 degrees where I can get damage. So my first objective with this tunnel was to keep it above that 27 degrees, which we were able to do, whereas outside it was dropping that level at night. The next is to keep it above the baseline. So by having that tunnel over it, I'm keeping it's immediately, as soon as the sun comes out, it's popping above that baseline, and I'm keeping it there for more hours per day, which is really what I'm after. And then really here, my optimum for strawberries is in the 70s, and I'm keeping it there for most of the day. Now, on this particular week, it actually did get up to 70 outside, but I'm keeping it there for much longer. Now, one thing to point out is that this flat line doesn't happen by chance. This is because we were ventilating and the tunnel, we were opening things up. Otherwise, on a sunny day in the winter, it can get 120 degrees in a tunnel, which is no good for strawberries. So kind of what we did, our system that we've used is using raised beds like I talked about before. This is a bed shaper that we use back of a small tractor. Forms these raised beds. We put drip tape down it. We actually use 2 lines of drip tape per row, one for each row of plants. We use black plastic mulch. One of the reasons we use this type of a tunnel, this is a easy tunnel to set up and take down, and we actually move it out of the way when we pull up our beds. If we had a bigger tunnel, we could actually pull that tractor through there. That works really well. Plastic mulch, we plant 12 inches apart this way and 12 inches apart this way in a staggered row. So these beds are about 28 inches wide, and we're using a staggered double row of strawberries down that bed. Our early spring production, I mentioned before, we're planting in September 1st. We're managing that tunnel in the fall to get good plant establishment and good flower bud initiation. We're using June bearing types, and we use plug plants, and these we can grow in a small greenhouse. And I've got a fact sheet on how to do that, and I'll talk about where to find that information later. During the winter, we might remove any flowers that form initially. We would remove any runners, which we typically don't get a lot of, and we'd try and keep that temperature between 40 and 70 degrees for as much of the day as we can in the fall, and then till once everything freezes, and then we kind of let them go. And then in the early spring, we close up the tunnel. We start to push growth until they start to fruit. There's another system for fall production I'm going to talk about later on. This is kind of what it looks like. So here's our experiment. We used raised beds. We used plastic mulch, just like I've talked about. We left some unprotected. We put some under low tunnels and some under high tunnels. This is the unprotected. This is our yields for the whole season in pounds of fruit per plant for unprotected and a low tunnel only. And you'll see that we got not very much fruit. And that's because this low tunnel is not enough to protect our flower buds. It just doesn't have enough thermal mass. It just is not effective. But if we put them in a high tunnel or a low tunnel plus a high tunnel, our yields were up around 1.5 pounds per plant. So this less than 1/4 pound per plant is not economically viable. I'll just tell you that right now. Without the use of a high tunnel to protect those blossoms, it just wasn't worth it for us. You can't make it work. It's just too poor yields. This is kind of our cumulative harvest to show you season. So this is the fruit as a cumulative fruit yield over the course of the season. And in this case, with our high tunnel alone, we started late April. We started in production, and then it terminated in mid-July. Okay, so this arrow shows where our field production started, but there was so little that it was very poor. And so with a high tunnel alone, we're pushing our production about a month earlier. With a high tunnel plus a low tunnel, it pushes it a little bit earlier still. And that's really, so not only are we getting more yields, we're getting them earlier. And that was by design. If I didn't want to do that, I could have delayed when I closed up the tunnels and started warming the soil. Another thing we looked at was in-ground supplemental heating. And in our case, we used electric heat cables that you use in greenhouses for bed heaters and things like that. And we are for bench heaters. We used these installed in the soil about 1 inch below the surface underneath the plants to warm that soil. And we just turned them on for a short period of time. This can be done other ways. This is a commercial farm in Vermont that I visited. They were using a propane powered water heater and small pumps and running little spaghetti tubing down through the beds to heat the beds with heated water, which is much more efficient than what we were doing. For our experiment, we heated the soil just in the spring to try and get the plants going, and we set the thermostat on these heat coils to 45 degrees Fahrenheit or 60 degrees Fahrenheit, and then ran them for a couple of weeks just to get the plants rolling. So this is back to that same slide I'll show you. So here, the light gray is where the field production started. This is high tunnels alone. If we did high tunnels plus low tunnels plus 45 degree, heating the soil to 45 degrees, we moved it slightly earlier. We got better yields. But if we moved that so that we were heating to 60 degrees to get them really moving, we moved it clear up into early March is when the yield really took off. In fact, we were picking ripe berries on Valentine's Day, just a few berries, but our real heavy production kicked off about towards the end of February. And for Cache Valley, that's pretty impressive. So that's what the plants were looking like. And that was one of our harvests in February, where you can see there's about 1 foot of snow on the ground, and we're picking these big, beautiful berries. So another approach, supplemental heating. So this is, again, for early spring production, plant in the fall, manage those tunnels through the winter, push early production. For fall production, we're using spring planted. We're planting day neutrals, which in theory will flower and fruit through the summer as long as temperatures are suitable. We use dormant plants because that's what's available. Our summer care is we remove any runners that form, and hopefully if they're fruiting heavily, they won't produce a lot of runners. And then we can continue when we're trying to get them to come into production in the summer and then continue into the fall. Now, when in Cache Valley, most years summers are too hot, so we don't get a lot of production. And this is 2 years when we did this. We planted them early spring in the tunnel. We got them established. They started to fruit in late June into July. We got a pretty good flush of fruit. And then the temperatures in August and September are too hot and they kind of taper off, and then we get some fall production going into October and November. This year we got a little better yields in the middle of the summer, but not great. But typical last harvest date for 2008, we picked fruit in the tunnels on the 15th of December. Not a lot of yields out that far, but pretty good yields in October for sure. In the field, once October hit, it was cold and everything was done, and we were still picking a lot of fruit out of these. Now, should mention that to keep this production going through the summer, we actually use shade cloth. So we had the tunnels covered in plastic to get them established. Once temperatures were above optimum, we took the plastic off, put shade cloth through the summer, and then as we were getting close to our first fall frost, pulled off the shade cloth and put the plastic back on to keep them going. Again, I talked about managing temperatures, the importance of ventilation and shade to keep that temperature from hitting this range of heat injury or this maximum for growth. Others have done this. This is one of my colleagues in Oregon, Claire Sullivan, who's in the kind of the center part of the state, kind of high elevation, colder conditions, and she used a system similar to ours, and she had 4 different varieties. These are all ever-bearing types, and her harvest season was from early July into September for some of these, and she got pretty good yields. The fact sheet that I'm going to refer to here, and I'll show you another way to get to it, is all of her results are published in a fact sheet there. Over the course of 2 seasons, so she planted in the spring of 2019, early spring in the tunnels. She got them established. So the gray, the lighter gray was her yields in the field in 2019, and then the dark is the field in 2020. This is high tunnels 2019, high tunnels 2020. So she kept that same planting over a second year and saw some really nice yields. For this particular variety, over the course of 2 seasons, you're almost 4 pounds of fruit per plant, which is really, really quite nice. High quality fruit. Other person that's working on this is my colleague here at USU, Dr. Jennifer Reeve. She's interested in organic management and particularly looking at varieties that are adapted to organic management. And this is where the discrepancy in my title came in, because I'm working closely with Jennifer on this project. Some of the things that we're looking for in an organic strawberry system is disease resistance, but a big one is nitrogen uptake efficiency. It's hard to get enough nitrogen in the soil to really push a lot of growth in an organic system, and the nitrogen becomes available kind of slowly. And so getting something that's really efficient at nitrogen uptake would benefit us in an organic system. And so that's what we're trying to do. But also in our soils, alkaline soil tolerance, high pH soils is really key. And so she's got variety trials at different locations. This is one of her cooperators in Cedar City, where they have different, and you can see the different varieties. This was taken in early spring. You can see some of them, these were fall planted. Some of them are dark green and lush. You can see a little bit of winter injury, frost injury, but here's another variety planted at the same time, managed the same, and look how yellow that is because of tolerance or lack of tolerance to alkaline soils. She's got the trial at the USU Student Farm. These are some of the varieties you can see. This is Camarosa. You can see the yellowing that we typically get. Jewel is much more green. This Galetta is really efficient at nitrogen and iron uptake. It looks beautiful even in our alkaline soils. Here's Chandler and Monterey. These are 2 of the ones that really struggle in high pH soils and how poorly they looked. Here, these graphs show, so this is the fall planted system that I talked about before. You can see this is a measurement of leaf chlorophyll, and some of these are really, the Galetta is one I mentioned, is really dark green and lush. And here's Chandler and Monterey, just to show you kind of the quantitative differences across these. Jewel, Yambu, Galetta are all looking really good. This a spring planted system. These are all day neutrals except for a couple of controls like Chandler that were included just for comparison purposes. And you can see they have a big differences in terms of their iron chlorosis tolerance as well. Another source of information, my colleague at New Mexico State did some trials on a number of varieties and about 10 years ago. And you can see she was seeing again differences in iron chlorosis and tolerance there. She tested a bunch of different varieties under their conditions in northern New Mexico up in high elevation conditions and results. And we've actually taken her results and worked with her and posted a fact sheet on our USU website with her results. So I want to talk about where to get this information. If you go to our website, you just type in tunnel.usu.edu. There's a fact sheet on temperature management in high tunnels. There's this guide for high tunnel strawberry production for this early spring harvest. That's that fall planted system I mentioned. And then this late fall harvest, which is the spring planted system that I mentioned, and it goes through step by step. There's also a link to Claire's paper or fact sheet that Oregon State University published and what they did there, and that there's also a fact sheet on plug plant production. With that, I'm going to stop. I'll stop sharing my screen, and we can. I'm happy to take any questions. If I've got a minute or two, I might be right up against my deadline there.
We got about 2 minutes, so.
Okay, if there's a quick question or two, if not, I'm happy to answer them online.
You got some pretty good questions on here. So the first one, I might just get through one, then we'll have you answer the rest of the Q&A.
Okay.
Do strawberries have a cold temperature period requirement?
Yeah, that's a good question. And so what's happening, and the answer to that, the standard answer to every question, if you're an extension, is it depends. What it depends on is the type. So with the day neutrals, they'll just keep fruiting. What happens with the June bearers is that they form those flower buds in a crown, and then they have to go through this dormant period before they start to flower and fruit again. And so with it just depends on the type. With the day neutrals, not really. They can be fruit. They'll just keep flowering and fruiting until they run out of. They can fruit themselves to death, literally. With the June bearers, they have to go through that dormant period and then they start to fruit again.